Hey everyone, and welcome to the Foundry by Forge College. In our previous explainer, Timestamping in Practice, Record Keeping and Trust, we explored how old-school registries build trust through, well, sheer physical redundancy and tamper evidence. We saw how analog methods acted as the world's original security systems. Today, we're taking a pretty fascinating leap. We're going to bridge that incredibly practical, historical record-keeping of the past directly to the academic synthesis you're going to need for your upcoming capstone project.
It's kind of the ultimate evolutionary question, right? How exactly did dusty paper ledgers become the cutting-edge blockchains we use today? For this explainer, I want you to step into the shoes of an intellectual detective. Now, your mission isn't to dust for fingerprints or, wear a trench coat. It's to find the missing conceptual links between those old wax-sealed notary ledgers and modern decentralized networks. We are going to connect the dots between what people were doing centuries ago and the actual code that runs Web3 today.
Okay, let's dive into this. Here's our roadmap for today. First, we'll be tracing blockchain's family tree. Second, we'll uncover 3 core intellectual links. Third, gathering types of evidence. Fourth, coding your timeline entry. And finally, validating your capstone work.
Section 1. Tracing blockchain's family tree. We are moving from practice to provenance. You see, it's one thing to understand the basic mechanics of how a tamper-evident seal works on a physical piece of paper, but it's an entirely different challenge to track the actual provenance of these ideas across the decades. Let's move to and see how this builds, because there are some massive milestones here. Back in 1991, you have Stuart Haber and W. Scott Stornetta mathematically chaining document digests together so they literally couldn't be backdated. Fast forward to the 2000s, and we see the rise of distributed notarization, basically spreading the trust around rather than relying on one single guy with a stamp. And that shift, it directly sets the stage for the modern blockchain networks we see today.
To properly prove a historical link between these eras, we actually have to use a concept called triangulation. This just means we need to neatly separate what a technology actually does from how it was used and the trust it created. Think of it as 3 buckets. You've got mechanism, which is the operational trick itself, like hashing a document. Then practice, which is how institutions actually used it out in the real world, like a public registry. And finally, implication, which is the argumentative effect. In other words, the real reason people trusted the system enough to do business on it.
Section 2, 3 core intellectual links. This is the conceptual DNA of Web3.
What we're really looking for here are the specific design patterns that migrated directly out of historical timestamping, survived the test of time, and were eventually hard-coded right into core blockchain architecture. So the crucial point is that these 3 specific mechanisms are the absolute backbone of the historical analysis you're going to conduct for your capstone. Number 1, chaining digests for tamper evidence, meaning each record mathematically locks the one right before it. Number 2, distributing anchors to reduce central trust, making sure there's absolutely no single point of failure. And number 3, enforcing an append-only chronology, which just ensures a permanent auditable trail where history can never ever be erased.
But remember our buckets. We have to keep our categories clear. Let's compare mechanism to implication. Let's be totally honest for a second. A clever technical trick, like running a document through a cryptographic hash function, isn't exactly the same thing as its legal or historical impact. A fancy math formula on a computer screen doesn't automatically mean a judge is going to trust it in court, right? The mechanism is the hash itself. The implication is the undeniable real-world proof that nobody altered the record. You really want to keep that distinction crystal clear for your analysis.
Section 3. Gathering types of evidence. Time to build your historical case file.
Sourcing reliable evidence and effectively categorizing your research materials, that's what separates a good capstone from a great one. Now, what's really interesting about this slide is when we break down our catalog into distinct categories, you can see how each type serves a highly unique role in proving lineage. Technical artifacts like raw code show the exact implementation. Primary documents, think patents, show the author's original intent. Institutional records, like archive logs, show the operational use out in the wild. And secondary analyses, like historical reviews, well, they help you situate all these artifacts within a much broader context. As you really start digging into your research, you're going to need to accept one fundamental truth. History is incredibly messy. As the quote here says, you will rarely have a single smoking gun source. You're simply not going to find one magical, glowing piece of parchment in some ancient library that says, here is the exact blueprint for Web3. It doesn't exist. Instead, you're going to have to build a credible chain of adoption by carefully combining multiple varied sources. To build that credible chain, you're going to rely on what we call the evidence triad. Honestly, think of this as your secret weapon for building an unshakable case file. You need technical artifacts to prove the mechanism physically existed in the first place. You need primary documents to prove the creators explicitly intended to solve a specific problem. And you need institutional records to prove that society actually put the practice to work. Combine all three of those, and your argument suddenly becomes bulletproof.
Section 4. Coding your timeline entry. Let's talk Python data classes.
Okay, gathering evidence is great, but we actually need a way to organize it. Now, if you aren't a master software engineer, do not worry. Structuring this historical evidence using Python data classes is quite literally just like pinning your clues to a highly organized digital corkboard. Here is how we build it step by step. First, you define your timeline data classes to create nice, compact, typed records. Second, you add your evidence items, categorizing them by type. Third, you explicitly map the historical mechanisms to modern concepts. And fourth, you just export everything to a clean dictionary structure. Breaking it down like this makes the concepts of timeline entry and evidence item classes feel incredibly approachable and super easy to synthesize later on.
Within all that code, the absolute most vital piece is the mechanism map. This is a dictionary field that's explicitly linking a historical practice, like those chained digests from 1991 we talked about earlier, directly to a modern concept, like blockchain block linking. This specific mapping function basically acts as the ultimate glue between the past and the present in your code. It's the exact spot where you formally declare, hey, this old idea is the direct ancestor of this new technology.
Section 5. Validating your capstone work. Let's automate the audit.
Because you've brilliantly structured your historical research as code, you can now write a small Python validator to ensure your case file is perfectly complete and rigorous. You are essentially automating the audit of your very own historical analysis. Your validator will just run a few simple checks. 1, it'll check that every single entry has at least one piece of primary or technical evidence. 2, it'll verify that your mechanism mapping isn't empty. And 3, it'll return a handy list of flagged problems if anything is missing. And this brilliantly illustrates how we can take highly qualitative historical standards and magically transform them into strict, automatable code checks. It completely ensures your logic is sound before you even write a single paragraph of your capstone.
So, with all that fantastic framework in place, here are your direct marching orders for the next lesson. You need to prepare for your capstone orientation. Before you begin the next module, I want you to go out and find 3 candidate artifacts so you're ready to go. Find 1 technical artifact, 1 primary document, and 1 institutional record. Bring their citations and just a quick note on how they connect to each other.
You have the theoretical framework, you've got the Python tools to structure your evidence, and you know exactly what kind of artifacts to look for out there. So I leave you with this final provocative thought. What historical thread will you uncover first? To continue exploring this fascinating subject and to dive deeper into our other Web3 learning resources, make sure you visit our website at forge.college. Happy hunting, detectives!